Hi students, so today we are over here with a new video, and in this video we are going to discuss a very beautiful problem from Pathfinder Physics for Olympiad and JEE Advanced. But again, don't be terrified or be carried away when I use such words like Olympiad or JEE Advanced. This question is equally important for students who are preparing or focusing for JEE Mains as well as NEET. Why? Because this question is from Newton's laws of motion and is a very interesting application of Newton's first law, case of equilibrium. We'll understand how equilibrium applies over here and how to solve the question properly. So let's see the question. Let me brief you about the question. We have a solid hemisphere which is fixed, and there is a small metal ball whose size is negligible compared to the size of the hemisphere, and this metal ball initially it was lying near the bottom and it is being gradually and slowly pulled when it is connected to a cord which passes over a pulley, and it is being gradually and slowly pulled by a force F. So what will happen? It will move up. So we have to consider the positions between the bottom of the hemisphere and the top point, and we have to see that what will happen to the applied force F and the normal reaction between the ball and the hemisphere. How will they change as the ball moves up on the surface of the hemisphere from the bottom to the top? Okay, so we have the options given. Now let's see, or let's analyze why we are going to use Newton's first law. Well, whenever you have such things in question that they use the phrase pulled slowly. When they say pulled slowly simply means that speed is very small, negligibly small, and it is almost assumed to be constant. It is not changing. So we can take in such case the acceleration of the ball will be approximately 0. So if acceleration of the ball will be approximately 0, so we can say net external force on the ball, this will be taken almost 0. So we can say case of first law. And if you see in total how many forces will be acting over here, there will be 3 forces. Why I am saying 3 forces? One will be the weight mg, which is fixed constant force. One will be the tension. Now tension will be equals to F, because whatever force is directly applied on the cord or string, that becomes the tension. And there will be, if you see this taken as the center of the base of the hemisphere, so we have one more force which is the normal reaction. In question they are taking it as R. So these are the 3 forces acting, right? And we have to apply first law. So we know that whenever we have 3 forces acting on a body and it is in equilibrium, we can directly apply Lami's theorem. So let's see how, with the help of Lami's theorem, we are going to solve this question easily and quickly. So I have already drawn the diagram once again where I have to mark the forces. So here, as I said, this force is W, which is fixed. Here we have the reaction force R, which I don't know whether it is constant or variable. We have to check that. And we have this tension, which is F. Right? Now, this is at a general instant. So if we are taking this particular instant where this cord makes an angle theta with vertical, so obviously theta will be variable. Now let's see that this clamp point and the base, if I take this point as O, if I take this point as A, and if I take the clamp point over here as B, so the separation between O and B will remain fixed with time. So I can take this height h. So we can say from here H is fixed. Now one more thing, this is the radius of the hemisphere R, so this R is also fixed. Now as the ball will move from the bottom to the top of the hemisphere, so you can see what will happen, that this length, if I take this length as L, so this length L decreases. So as the ball will go up, this length will become shorter and shorter because this length is increasing, right? So what we can see, this angle theta I said is variable. Let's take one more angle over here. Let's call this angle as phi. So this phi is also variable. Now, if this is phi, this is theta, so sum of internal angles is equals to external angle, so this angle will become theta plus phi. Clear? What more? If this is phi, this is vertical, this is also vertical, so we will say that this angle will also become phi. If this angle is phi, then we can say this will be 180 minus phi. Clear? And if I name this particular angle as alpha, so we can see that this being a straight line, what is alpha? Alpha is 180 minus theta plus phi. So these are some important things that we have. H, R, they are fixed, L is variable. Now if I apply Lami's theorem, because three forces are acting and the ball is in equilibrium, so Lami's theorem on the ball, so what we will do over here simply is, we will take first force F and divided by sine, which angle? We have sine phi. Then if we take weight, then we have to take the angle. I'm sorry, I think I made a blunder over here. Let's quickly correct it. We have to take force F and the angle in between weight and R. So weight and R angle is 180 minus phi. Now when we are taking W, then we have to take the angle between F and R, which is theta plus phi. You can see in the diagram. So sine of theta plus phi. And when we take R, so we have to take the angle between F and W, which is alpha plus phi. But if you see, alpha is 180 minus theta plus phi. So if you break the bracket, it will become 180 minus theta minus phi. So alpha plus phi from here will simply become 180 minus theta. Alpha plus phi is how much? 180 plus 180 minus theta. Now knowing very well, sine 180 minus theta is sine theta only. So from here we can write F by sine phi will be W by sine theta plus phi, and R by sine 180 minus theta becomes sine theta. So let's write these two forces in terms of W. So F will become W sine phi by sine theta plus phi, whereas R will become W sine theta by sine theta plus phi. Now here also you may feel that it's too complicated. Why? Because W is constant but theta and phi both are variable. So how can we check whether force F or R, they are increasing, decreasing or remaining constant? Well, we have one more important case which everyone, I am sure that you are aware of, which is called as sine rule in a triangle. Sine rule in a triangle, when applied to vectors, it becomes Lami's theorem. Both are same only. So in sine rule, we relate the sides of a triangle with the angles opposite or facing those sides. Okay. So if I apply, why I am applying sine rule? Because I want to make these expressions simpler. So sine rule in triangle OAB. So what will I say by sine rule? If I take sine of theta, so if I take theta, then I have to take the side in front of it. What is that? R. So sine theta by R. Now if I take alpha, then for alpha I have to take opposite is H, and if I take the third angle phi, then I will write L. But what is sine alpha? Sine alpha will become sine 180 minus theta plus phi, which is sine theta plus phi only. So from here we can write sine theta. What I said, sine alpha will become sine theta plus phi, because alpha is 180 minus theta plus phi. So sine alpha will become how much? Sine of theta plus phi. This I hope is clear. So sine theta by sine alpha, or sine theta by sine theta plus phi, what value are you getting? Sine theta by sine theta plus phi, can you write, is R by H. Sine theta by sine theta plus phi is R by H. And similarly sine phi by sine theta plus phi, this will become how much? Sine phi by sine theta plus phi will become L by H. That's it. Now can you see sine phi by sine theta plus phi? Sine phi by sine theta plus phi is L by H. So we get the expression for F. So F will become W. Sine phi by sine theta plus phi is L by H. So W into L by H. Let me quickly write over here. So from here we are getting F is equals to W L by H. And what about R? R is W sine theta by sine theta plus phi. Sine theta by sine theta plus phi is R by H. So W R by H. So R becomes W R by H. Now this tells you everything. See how why W is constant, H is constant, and R is also constant. So this capital R becomes constant. It does not change. And here you can see W is constant, H is constant, but L we know is decreasing. As we are going up, this length L I said is decreasing. So if L decreases, so F is directly proportional to L. So F will also decrease. So as the ball goes up, F decreases, R remains fixed. Which option will be correct? F decreases, R remains fixed. We have the third option to be the correct one. I hope this is clear. Once again showing you, we got the expressions over here, and from here we got the value of sine theta by sine theta plus phi and sine phi by sine theta plus phi. So once we know these values, we just substituted in F and R and we got the final result. F is WL by H, directly proportional to L, so decreases. R is W into radius by H. All the three terms are constant or fixed, so R will remain constant. But this is up to the point from the base to the top. So I hope this question is clear to all of you, and I am sure that you found it interesting. So stay tuned for many such more important questions to come, and also comment if you want any particular topic or any concept which you want a discussion of. So please let me know about that also. Do like, do subscribe and share with your friends also. Thank you.